All right, so I think this is recording. Let's take a look here. We have a 3 by 3 system of equations to solve. It has x, y, and z, but actually if we look at that third equation, I don't see an x there. So what I would do if I were you is rewrite this and number these equations. So negative 6x minus 3y plus, and I'm going to put a 1z there just to help me out, is equal to 0. And I'm going to call this equation 1. And equation 2, 6x minus 1y minus 2z is equal to 16. And I'm going to call this equation 2. And my final equation here, I don't see an x, so I'm going to write in a 0x and minus 3y plus 1z. Now, when you're solving a 3 by 3 system, we often tell you to look at the coefficients in front of the variables and look for numbers that are equal and opposite, like the 6 and negative 6 here. Or sometimes you'll look for coefficients that are the same number, like a negative 3 and a negative 3, or a positive 1 and a positive 1. Now, in this situation, we're going to be solving this by elimination. So you'll pick two equations and you'll eliminate a variable. Well, I can see that equation 3, they have already eliminated the variable x for me. Equation 3 does not contain x. So what I'm going to do is look at equations 1 and 2 and see how easy it would be to eliminate x using equation 1 and equation 2. And as it turns out, it would be very easy because the coefficients are equal and opposite. All I have to do is add equations 1 and 2 together to get a new equation, and that new equation will not have the variable x. So I come down here and I have negative 6x minus 3y plus 1z, and I'm going to add to that on the left-hand side 6x minus 1y. So this is why it's important to line up the variables so that it's easy to add or subtract equations. The resulting equation will not have any x's. The negative 6x and positive 6x are going to cancel. And here these y's now add up to negative 4y, and positive 1 and negative 2 adds up to a negative 1, and 0 plus 16 is 16. So I'm going to call this new equation equation 4. And if I look at equation 3 and equation 4, they have something in common. They don't contain an x. So I'm going to look and say, all right, I've eliminated x. Now I want to either eliminate the y variable or the z variable. Which one am I going to choose? Well, if I look at the y's, I've got a negative 3 and a negative 4, and those don't add up to 0. You know, we could cancel it if we wanted to, but it'd be a little bit more work. If I look at z, I've got a positive 1z and a negative 1z. If I add these equations 3 and 4 together, I'm going to eliminate the variable z. So that's going to get me with one variable, and that's what I want. So I have negative 3y plus 1z is equal to 12. And that's equation 3. And if I take equation 4, which is negative 4y minus 1z, is equal to 16. If I add these two equations together, the resulting equation is negative 7y. The z's are eliminated. They cancel. And now, this is 28. It's very easy to solve for y. I divide both sides of this equation by negative 7. Let's do it. I divide both sides of this equation by negative 7. And the negative 7 divided by negative 7 is positive 1. And I have that y is equal to negative 4. So now it's very easy to substitute into these other equations to figure out what x and z are. I can use either equation 3 or equation 4 to figure out what z is. So let's just come up here and use equation 3 right here. And if I write that over here, I'm running out of room, so if I write this equation 3, negative 3y times y, but I know what y is. I can replace y with negative 4. And then I've got plus z is equal to 12. So I have, negative times negative is positive. So I have 12 plus z is equal to 12. Well, that's obvious that z is 0 because 12 plus 0, 12. So now I have y and z. If I come back up to the original 3 equations and use either equation 1 or equation 2, I'll be able to figure out what x is. Let's try to shrink. Oops. I'm getting used to this new software. And it doesn't always cooperate or do what I hope that it will do. I'm hoping that I can just shrink this, there we go, and give myself a little bit more room to work. All right. Now, I haven't figured out what x is yet, so like I say, let's use equation 2. I've got 6 times x minus y, but I found y to be negative 4. And then minus 2 times z, but we have minus 2 times 0, and that equals 16. So we have 6x plus 4, the double negative there, and this guy is just 0, is equal to 16. So we have what they refer to as a two-step equation. In 2 steps, we'll have our answer. So if we subtract 4 from each side, then we have 6x is equal to 16 minus 4 is 12. And in my second step, my first step was subtract 4 from each side. Now divide each side by positive 6, and we have our solution to this equation. X is equal to 2. So we have found that the system of linear equations, these 3 lines of 3-dimensional space all intersect at the point 2, negative 4, 0, and that is choice A. So I hope that helps, and I will talk to you later. Bye.